How Virgin Atlantic used Codex to ship a mobile app on a hard deadline. 0 P1 defects at launch. Near total test coverage. A hard holiday deadline. Virgin Atlantic hit all three using Codex, and it is a repeatable playbook you can steal right now. Let's break down exactly how they did it, step by step, and what you as an operator can copy today. Why this matters for operators. Fixed deadlines are the real test, not demos, not prototypes. Deadlines where a product has to work in front of millions of customers on a holiday travel week with no room for emergency patches. Virgin Atlantic shipped a revamped mobile app under exactly those conditions. They used OpenAI Codex, an AI coding agent, not just autocomplete, to compress their development cycle without cutting corners on quality. In the same week, RAMP engineers published their own numbers. Code review time dropped from hours to minutes using Codex with GPT 4.5. Two separate companies, two separate use cases, same tool, both shipped. That is not a coincidence. That is a workflow pattern worth understanding. What Codex actually is in this context. Quick clarification before the walkthrough. Codex here is not the old 2021 API. This is OpenAI's agent-based coding system built on top of their frontier models. It runs tasks in isolated sandboxes. It can read your codebase, write code, run tests, and return results without a human sitting in the loop for every step. Think of it as a contractor you can spin up at 2 a.m. who already knows your code base. Virgin Atlantic's team used it to parallelize work that would normally block on senior engineers. Instead of one or two people bottlenecking the entire sprint, Codex handled the repetitive, high-volume work, writing unit tests, scaffolding boilerplate, catching regressions. That freed the senior engineers to make architectural decisions, review edge cases, and stay focused on the parts that actually require human judgment. The workflow, step by step. Here is how you replicate this, whether you are a two-person shop or a larger team. Step 1. Define the hard constraint first. Virgin Atlantic started with the deadline non-negotiable. That is the right move. When you give an AI agent a fuzzy scope, you get fuzzy output. When you say, this ships on November 15th, here is the feature list, here is the test standard, you get a scope task the agent can actually execute against. Before you prompt Codex, write your constraint document. 1 page. What ships? What the acceptance criteria are. What test coverage threshold you require. Step 2. Set the test coverage requirement as a hard gate. Virgin Atlantic achieved near total unit test coverage. That did not happen by accident. They set it as a requirement, not a nice-to-have. In your workflow, that means your prompts to Codex should include explicit instructions like, every function you write must have a corresponding unit test. Do not mark a task complete until tests pass. This is a prompt pattern. It is learnable. It is repeatable. Step 3. Use Codex in parallel, not in sequence. This is the leverage point most operators miss. Do not use AI coding agents like a faster junior developer who does one thing at a time. Spin up multiple parallel tasks. While one Codex instance is writing tests for Module A, another is scaffolding Module B. Your engineers are reviewing output from both, not waiting for either. Virgin Atlantic's team explicitly leveraged this parallelism to hit their timeline. That is the architectural shift. It is not faster code. It is concurrent work streams that previously required more headcount. Step 4. Stage the reviews. RAMP's workflow is instructive here. They used Codex to do first-pass code review, catching issues that are real but tedious, naming inconsistencies, missing edge case handling, style violations. Their engineers then do a second-pass review focused only on logic and architecture. 2-stage review. First stage is AI speed. Second stage is human judgment. Total time drops from hours to minutes on the first stage alone. You can implement this immediately. Set up a Codex task that reviews incoming pull requests against your style guide and your test requirements. Have it return a structured report before any human looks at the PR. Step 5. Build the prompt library, not just the output. The most durable thing Virgin Atlantic built is not the app. It is the prompt patterns that produced the app. Those reusable instructions are now institutional knowledge. Next deadline, next sprint. The team does not start from scratch. For your operation, that means every workflow you run with Codex should end with you saving the prompts that worked. Build a prompt library. Version control it alongside your codebase. That is the compounding return. How I would build this. For the actual code editing and iteration layer, I have been using Cursor, the AI code editor that actually understands your codebase, not just the file you have open. It is where I would run the Codex-style workflow on a real project. Cursor handles the context window problem that kills most AI coding setups because it indexes your whole repo. I may earn a small commission if you use the link in the description, full transparency. The way I would use this: Cursor for the in-editor iteration and active development, Codex agents for the parallel, long-running tasks that run overnight or between stand-ups. They are not competing tools. They slot into different parts of the same workflow. Common failure points. Failure. Point 1. Vague acceptance criteria. If you do not define what done means, Codex will define it for you, and you will not like the answer. Be specific. All tests pass at 95% coverage is a criterion. Good quality code is not. Failure point 2. Skipping the two-stage review. Operators who let AI-generated code go straight to production without a human second pass are compressing in the wrong place. The review stage is where you catch the 5% Codex got wrong. Do not skip it. Failure point 3. Not saving prompts. If your workflow is not documented, it does not scale. Every time a new engineer joins your team, they start over. Treat your prompt library as a first-class engineering artifact. Commit it to the repo. Failure point 4. Using agents sequentially when you can go parallel. This is a throughput problem. If you are running one task at a time, you are not using the tool correctly. Map out which tasks are independent and run them simultaneously. That is where the time compression actually comes from. The downloadable artifact. The link in the description has a prompt template you can drop into Codex or Cursor today. It includes the constraint document format, the parallel task prompt structure, and the two-stage PR review prompt that mirrors what Ramp's team implemented. Grab it and adapt it to your stack. Who can implement this today? You do not need Virgin Atlantic's engineering budget. You need 3 things: a defined deadline, a test coverage standard, a willingness to run parallel tasks instead of sequential ones. If you are a solo operator with a dev background, you can run this workflow with Cursor and the Codex API starting this week. If you manage a small engineering team, you can implement the two-stage PR review with almost no setup time. The constraint is not tooling. The constraint is workflow design. Most operators are still using AI coding tools like a faster keyboard. The teams shipping on hard deadlines with 0 P1 defects are using them like an OPS layer. The operator take. The teams winning with AI coding agents are not using them for speed alone. They are using them to run more work streams simultaneously than their headcount should allow. What is the hardest deadline you are staring down right now, and have you actually set up parallel agent tasks for it?